Alright, so in the second video, sorry, we're going to have a look at factorizing polynomials, and in particular we're just going to look at cubics, but this same process can be applied to any higher order polynomial. So, you might have a quartic or quintic equation, and they can all be factorized in this way. So the first method I'm going to look at applies to these first two problems, and I'm going to use the method of factorizing by grouping 2 and 2. This is a method which you have learned about when doing, in the quadratics topic. And all I'm going to do is recognize that these here have some kind of common element. And so what I'm going to do is, from these first two terms, I'm going to take out the common factor of x squared. That leaves x minus 5. From the second lot of two terms, I should say, I'm going to take out 2 as a common factor, which also leaves an x minus 5. So I can see now that there is a common factor of x minus 5. I can take that out, and that leaves x squared plus 2. And x squared plus 2 cannot be factorized any further because that is the sum of 2 squares. So in this next one, we're going to do the same thing. We're going to group 2 and 2. I'll take out the common factor of x squared in the beginning, and that leaves x plus 4. I'm going to then take out a minus 3 as a common factor, and that leaves x plus 4 as well. So then I have a common factor of x plus 4. And that leaves now x squared minus 3. But x squared minus 3 is different to 2 squares, so that can be factorized further. And that ends up becoming x plus 4, and then x plus root 3, and x minus root 3. So in that case, we're able to get it down to 3 linear factors, whereas in the previous example, it was 1 linear factor and 1 quadratic factor. All right. So this is a process that we should always check to see if we can solve them in this way, because I think that that's definitely the nicest method. Okay. In this third one, you can sort of look at this and tell that there isn't really a way that we could use that grouping 2 and 2. And so in this case, we have to use another approach, and this is where the factor and remainder theorems become quite important. Because what we have to do is we actually have to guess the first factor. Now, there is a little bit of a method to the madness. So basically, what we're going to do is we're going to guess numbers and substitute them in and try to get it so that the remainder is 0, so that we have a factor. And what I'm going to do is I'm going to guess factors of this number here. Now, for the purposes of just about any question that you will do without a calculator, I would say that your guess is probably going to be between -3 and +3. Like, that will happen 95% of the time. I have only encountered actually one problem where it has required a guess outside of that range when we're talking about tech-free problems. So let's start trying numbers. I'm going to try factors of -24, so I could have plus or minus 1, I could have plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. And I really don't want to go any further than that. So we're going to start trying these numbers. Now there's a lot of even numbers there, which means I'm not going to... No, that's not necessarily true. All right, what I'm going to do is I'm going to start with... let's do 3. All right, so try P of 3, and we'll just see if this works. So P of 3 equals 3 cubed plus 3 times 3 squared minus 10 times 3 minus 24. So that's 27 plus 27 minus 30 minus 24. And, well, actually that's worked beautifully. That was a very lucky guess. Okay, that doesn't always happen. So, sometimes you can try several guesses before you actually get these. But anyway, that was really, very fortunate. Now, there is, something that you can do here to make life a little bit easier is we can often rule out 1 and -1 very quickly. And that's because basically the coefficients would have to add to give 0. So, like, I know that if I substitute 1 into here, I would get just 1. And if I were to substitute 1 into here, I would get 3. And if I were to substitute 1 into here, I'd get -10 and then -24. And those numbers clearly wouldn't add to give 0. And so, same thing if we used the -1. But anyway, now I found that P of 3 actually worked. It gave a remainder of 0. And so that means, therefore, that x minus 3 is a factor. Remembering that we changed the sign of it. Okay? So now that I know that x minus 3 is a factor, what I'm going to do is I'm going to divide it off, and we'll hopefully be left with a nice quadratic that we'll be able to factorize further. So put the x minus 3 there, and the x cubed plus 3x squared minus 10x minus 24. So I'm going to put x squared there. That gives us x cubed minus 3x squared. Take that away. That leaves us with 6x squared minus 10x minus 24. So that means I need to have a plus 6x here. That gives us 6x squared minus 18x, which we'll take away. That leaves us with 8x minus 24, and so I get a plus 8 there, which gives us 8x minus 24, and luckily leaving us with a remainder of 0. So I can say that when I have x cubed plus 3x squared minus 10x minus 24 divided by x minus 3, I get x squared plus 6x plus 8. I can actually rearrange this really quickly and easily by multiplying by the denominator. And so I can then say that x cubed plus 3x squared minus 10x minus 24 equals x minus 3 times x squared plus 6x plus 8. And that quadratic factor should factorize fairly nicely. So we've got x minus 3, and then two numbers that multiply to give 8 and add to give 6 should be 2 and 4. So x plus 2 and x plus 4. And now that is completely factorized. So this process is a bit more drawn out. There's quite a bit in it. Okay, and as I said, I was very lucky to get that first guess. That was unreal. It's not unusual to have to try 3 or 4 times to actually get one. But with a little bit of number sense and just thinking about the problem, you can kind of get a bit of an idea of what the number might be to begin with. And obviously you can also use your calculator to help make this process a bit more efficient. So if we use the calculator, I'll just bring it up here. Sorry, just give me a second. Alright, so what I can do is I can type in the original problem, x cubed plus 3x squared minus 10x minus 24, and then I can just factorize it by going highlighting, interactive, transformation, and then factor, and there we have it. Obviously, if you were to get surds in those factors, then you would need to use R factor instead. So again, you can just use R factor all the time. That will always work for you. And the other thing is, it doesn't matter which order these factors are written in, because we are just multiplying things, you know, 5 times 10 is the same as 10 times 5. So it doesn't matter which order we do them in. However, I would say that I generally write them in ascending order. So you notice I had the x minus 3 first, and then the positive 2, and then the positive 4. That's just my way of doing it. You can also go descending order, or you can just do whatever you want. It doesn't make any difference. Anyway, I'll leave the video there, and see you for the third one shortly.